Hey, hello and welcome to today's GFG problem of the day. Hope you're doing well. So let's see today's problem, majority vote. So what the problem is saying is we'll be given an array of integers where each number represents a vote to a candidate. Okay. We have to return the candidates that have votes greater than 1/3 of the total votes. Okay. If there's not a majority vote, then we have to return -1. Okay. So what the problem is saying is this each element, right? It represents a vote to a candidate. Now, 2 is a candidate, right? 1 is a candidate, 5 is a candidate. So it represents that this particular vote was given to this particular candidate. Okay, so we want to return all such candidates, right, whose frequency is greater than 1/3, right, 1/3 of the size of the array. For example, here, what is the frequency of 5? It is 4, right? And what is the frequency of this array? It is there are 11 elements. Okay, so 11 divided by 3, what it gives us 3, right? So 4 is greater than 3. So 5 is a candidate who has majority more than 1/3, right? Again, 6 is a candidate because it has the frequency basically is 5, which is again greater than 3. Okay, so these are the two candidates whose frequency are greater than 1/3 of the size of the array. Okay, so this is the ask, right? This is the ask. Now, how can we solve the problem? So the brute force or the naive approach can be definitely, if this would have been, if the space complexity would have been O of n, then simply we would have used map, right? Wherein we would have inserted the elements, right, and the frequencies basically, and whoever whichever elements frequency becomes greater than n/3 will simply return those elements. Okay, but here the space complexity is O of 1, right? O of 1. The space complexity is O of 1. Now, how can we solve this problem? Okay, so there's this standard algorithm called Moore's voting algorithm. Okay, Moore's voting algorithm. So this algorithm is related to finding out an element, whose frequency is greater than n/2. The size of the array, n is the size of the array, whose frequency is greater than n/2. And this algorithm enables us to solve the problem in time complexity with O of n and space complexity is O of 1. So this particular problem is based on Moore's voting algorithm only with slight changes. Okay. Now here. So whenever there is, we have to find out what Moore's voting algorithm is say is we want to find an element, right, whose frequency is greater than n/2. So the element in this case it is going to be 1. But now here they are asking, we want to find out the candidates or elements whose frequency is greater than n/3. So in this case, the max elements, the max elements can be, the size can be 2 elements basically. The max can be 2 elements. Okay. So we are going to use the Moore's voting algorithm only or similar lines. Okay. So what we are going to do is we are going to take two variables, for example, num1 and num2. Okay, num1 and num2 we are going to take. So num1, uh, uh, okay, so we are going to take num1, okay, we are going to initialize with int max basically. Okay, int max. Okay, and we are going to take another variable called frequency1 to keep track of the num1 basically, and we are going to initialize with 0. Similarly, we'll have another variable num2, right? Again, we are going to initialize with int max, right? And we'll have corresponding frequency 2 variable. Okay. Now what we are going to do? We are going to iterate through each element. Okay. Okay. And what we're going to check is if this particular element, let's call num. Okay, num. If this particular element, if it is equal to num1, okay, it is not equal to num1. So we're going to move on to another condition. Is it equal to num2? No, it is not equal to num2. Okay. We'll move on to third condition when we'll check if is frequency if frequency 1, if it is 0. Yes, it is 0. Then in that case, what we're going to do, we are going to initialize num1 with 2. Okay, and we'll also increment the frequency 1 with 1. Okay, now we are going to move to the next element. Okay, we'll check again if if 1, if it is equal to num1. No, it is not. Second condition, we'll check with num2. No, it is not. It is not equal to num2. Third is we're going to check if frequency 1, if it is 0. No, it is not. Fourth condition is we're going to check if frequency 2 is 0. Yes, it is. Then we're going to initialize num2 with 1, and also we're going to increment the frequency 2 basically. Then we'll move on to the next element. Okay, now the first condition again we'll check if it is equal to num1. No, it is not. The second condition is to check with num2. No, it is not equal. It is not equal. We'll check the third condition if frequency 1, if it is 0. No, it is not. Fourth condition, if frequency 2 equal to 0, it's not, right? Now fifth condition, now no condition matches, right? So in that case, what we're going to do is this particular element, right? This particular, it does not matches. So what we're going to do, we are going to decrement the frequency of both frequencies, frequency 1 and frequency 2. Okay. Okay. Now we are going to move to the next element, right? To the next element. Now we are going to check if this num, if this 5, if it is equal to num1, no, it is not. If is it equal to num2? No, it is not. Is frequency 1 equal to 0? Yes, it is. Then we are going to increment the frequency 1, and also we are going to initialize num1 with 5. Okay, num1 with 5. Okay, now we're going to check, we're going to proceed ahead. We're going to check if this num, is it equal to num1? Yes, it is. Then we're going to increment the frequency. And then we're going to move ahead. Again, we'll check if this num is equal to num1. Yes, it is. 5 is equal to 5. We're going to increment the frequency. Okay. Now we'll go here, move ahead to 6. Now we're going to check here. Is num equal to, is 6 equal to num1? No, it is not. Is 6 equal to num2? No, it is not. It is not, right? Then we are going to move to the third condition. Is frequency 0? No, it is not. We are going to move to the fourth condition. Is frequency 2 equal to 0? Yes, it is. Then in that case, we are going to increment the frequency 2, and we are going to initialize num2 with 6. Okay. Then again, we'll move ahead to the next element. We'll check, is 6 equal to num1? No, it is not. Is 6, then we'll move on to second condition. We'll check, is 6 equal to num2? Yes, it is. We're going to increment the frequency. Okay, we're going to increment the frequency. We'll go more to the next element. Again, the same conditions. This time again, this num2 is going to match, right? We're going to increment the frequency. We'll move ahead, right, to the next element. We are going to increment the frequency to the next element. We'll again increment to the frequency. Okay, now we have two nums, right? Num1 and num2. Now these are potential candidates or elements whose frequency can be greater than n by 3. Okay, greater than n by 3. Okay, they need not necessarily be the candidates. Basically, their frequency can be lower. Now what we're going to do, now we have num1 and num2, right? We have num1 and num2, and we will now reset this frequency 1 and frequency 2 to 0, and we will iterate through the elements of the array. Okay, and we will calculate the frequency. Basically, we'll check whether this num is equal to num1, right? And we'll calculate the frequency. Finally, we'll have the frequency of 1 as 4 and frequency 2 as 5, right? So these elements, they do qualify the condition, and hence we are going to return these elements basically. Okay, so this is the intention behind solving the problem. I hope you'll understand better when we code. Okay, so before going to the code, I'll request you to subscribe to my channel, like the video. Okay, let's quickly see. First, I'll show the Java code followed by C++. So let's first take two variables. Num1 integer dot max value, right? Similar, we are going to take num2, then we are going to take f1, let's say frequency 1, then f2 frequency 2. Okay, now what are we going to do? We are going to iterate nums, right? We are going to iterate nums. Now we're going to check the first condition. As I told, num equal to num1. If it is equal to num1, then increment the frequency, right? F1 basically. Similarly, else if we'll check if num equal to num2, then we are going to increment f2. Okay, again we are going to check here what is the third condition. If f1 equal to 0, right? If it is the case, then we will assign num to num1, right? And also we'll make f1, or we'll increment f1 basically, right? Similarly, the fourth condition is else f2 num2, right? And f2. And the fifth condition, if none of the condition satisfies, then we are going to decrement. We are going to decrement f1 and f2 both. Okay, f1 and f2 both. Okay, so here we'll iterate all the elements of the array, and then we are going to do what? F1 equal to 0 and f2 equal to 0. We now have the potential candidates in num1 and num2. Okay, so we are going to now check the frequency again. Okay, so in num equal to, let's iterate again this array. So we're going to check if num equal to num1. If it is the case, then simply increment f1. Here we'll check if num equal to num2. Okay. Now what are we going to check here? If f1, let's take the size of the array as well. What is nums, right? Nums, it is size. if it is n by 3, if it is greater than n by 3, then yes, let's add into the result. Do we have result? No, we don't have yet. So list integer result equal to new array list. Okay. So result dot add num1, we are going to do that. If f2 is greater than n by 3, then we'll add num2, right? And what the condition says, if there's not a majority vote, then return -1. So we're going to check if result dot is empty, right? If it is empty, then simply add -1 to the result and return the result. Okay, let's compile. I hope it compiled successfully. Yes, it is compiled. Let's submit it. I hope you have got the solution. Please subscribe to my channel, like the video. It will really be helpful to me. Yes, the test cases are being processed. Yes, thanks for watching. Let's quickly see the C++ code. It's almost same. I don't want to I shouldn't repeat again. Yes, but I'll attach definitely the code in the comment section. Okay. So here it is, like I don't think so I should explain this. Okay, you can go through the code. Also I've explained the intuition and the Java code as well, which is similar. Okay. Thanks for watching. Please subscribe to my channel, like the video. Have a happy, healthy and a great day. Thank you so much.